Okay. Good morning, everyone, and thank you for joining us for this webinar titled Cloud Computing, Operation and Data Issues. This webinar is presented by New Horizons partner, Management Mechanics' very own Eric Bloom. My name is Brian Duncan. I'll be your MC for the event. And what that means is that if you have any questions, please feel free to put those in the questions or chat box, and I can help relay those to Eric throughout the webinar so he can answer them appropriately. So this webinar, as all of our webinars, is sponsored by New Horizons. Who is New Horizons? We're a proven worldwide training provider with flexible learning solutions covering a broad spectrum of topics taught by industry-leading instructors. A few little bullet points there about us. With that being said, I would like to go ahead and pass it over to Eric so he can really give you the information that you're here for today.
Thank you, Brian, and thank you to New Horizons for sponsoring these. By the way, I should say to all on the line before I introduce myself that this is a monthly webinar that I do with them. So if you enjoy me or just enjoy the topics and basically suffer through me, is that I hope the material will be of value to you. Our next one will be on, I'm just checking the date, will be on May 10th on what is your productivity cocktail. And actually that's based on a new book, the one shown here, Productivity Driven Success, which I'm proud to say it was available on Amazon last Friday. I didn't even have a chance to tell you, Brian. It literally is hot on the presses, but available. Anyway, my name is Eric Bloom. By the way, from here, after this slide, for those who haven't been on with me before, just going to tell you who I am and then poof, 58 minutes of content. But anyway, my name is Eric Bloom. I'm a former CIO, have 25 plus years experience in IT, and have had my company Managing Mechanics for, I can't believe it, over 7 years now. I think 5 or 6 of which anyway have been in business cooperation with New Horizons, I'm very proud to say. I write for CIO.com. My column's called Driving IT Productivity, written for IT World. For a number of years. My column's called Your IT Career, Professional Coach. I do a lot of keynote speaking, and in fact, as shown here, I'm the past president of National Speakers Association New England, and you can follow me on Twitter at Eric P. Bloom, should you decide that my words of wit and wisdom are of value to you. Anyway, is that if I can also say regarding any questions that you have, feel free at any time to type them into the chat box, and Brian will interrupt me at an appropriate moment, or we can answer some questions at the end should that be a better place for them to be. But fire them up. Love your input. Love your questions. At the end of the day, I think we can learn as much from each other as we can learn you can learn from me. Now, going back to today's topic, just going to go back up here for a minute, it's cloud computing. So what we're going to do is we're going to talk about it not as what is cloud computing. I'm figuring anyone on the line who's interested in operational and data issues, we're going to be digging down a little deep. I personally love this topic because among other things, prior to my CIO role, I went up the app dev, the application development chain, implemented various cloud applications. I was also a DBA in my past, so I love app, I love data, and that's really partially why I love doing this type of webinar on a more technical topic. Anyway, let's start. We have just 3 diagrams at the beginning for those who aren't diagram oriented. But what will happen is I want to set the mood and set the stage for the issues or let me say for the things that cause operational and data issues when you move from a traditional based environment, namely everything inside your firewall, out to the cloud. Now, if you're working with private cloud and have those type questions, what I would say is put those questions inside the chat box, because these first 3 slides and various of the things that I'm mentioning in here it's cloud as it relates to third-party providers, as opposed to using cloud-based architecture within your data system to basically, use common machines and things along that line. I can answer questions on that, and we'll touch on it throughout. But primarily, I'm looking at working with third-party providers, the way that this particular webinar is architected. But anyway, this is your traditional data center. What happens is you have 3 internal systems. I'm figuring that, as my wife calls me, Mr. Obvious, is that would be labeled as System 1, System 2, and System 3. And then what happens is they're all running together in your data center, within your firewall, all being managed by the box on the top, which is your daily and nightly production operations. In other words, the same people who are running the batch jobs for System 1 running it for System 3. They may have slightly different skill set. It might be a slightly different technology. It might be mainframe JCL versus Unix scripts or Linux scripts also, but you know, or Windows-based apps. But what I'm saying is basically is that they're all being run under the auspices of the internal data center operations group. Now, the arrows between these systems, look at those as being data flow. So in other words, is if you think about, you know, as systems grew within a company, what you basically have is, if you look at most sort of, you know, larger, successful, more advanced IT shops, if you look at the data flows that go between all of the different systems, what you'll find is it looks a little bit like a plate of spaghetti. You know, you're now implementing System 3. You need data from System 1 and data from System 2. So, you know, what you do is you just talk to the people. They're all internally at your company. You talk at the people in charge of those systems. You get the appropriate data feeds, and depending on the amount of data that's needed, excuse me, and the size of that data, you know, what it might be is it might be something like web services, where you're pulling a specific, say, name and address on demand. Or if you're doing analytics of some sort, what it might be is a pass of all of the data, and so on, from system to system. Or, you know, if you're all internally in the same firewall, and let's say all of these applications are written on either DB2 or Oracle or SQL Server or whatnot, it's conceivable that System 2 will go directly into the underlying data structures, basically run stored procedures or whatnot directly against the data designed for Systems 1 and 3. Very efficient, been done this way for lots of years, etc. Then what will happen, the box on the bottom, is that, you know, what that is that's your general, you know, data warehouse. I use central data repository to make it sound a little bit generic, because it could be more than what you think of as a warehouse for analytics. Could be operational data. What it could also be is some core systems. For example, if you're in financial systems, then what that could be is under the central data repository, that could be your security master file. If you're in manufacturing, that could be your bill of materials. You know, etc. Or if you're in retail, it could be your core inventory system. So in other words, is that what happens with some of these bigger data repositories that affect multiple applications is they're actually maintained separately, and in this case tapped by Systems 1, 2, and 3. So this is your typical data center, certainly made much more simplistic, but you get the idea. Now let's move to a cloud format. Now what I'm going to do, take a quick look at this slide, just where the things are. I'm going to pop back to the last slide, just so you can take a quick look at it in comparison. So that's this one. This is the one I reviewed. Note that this doesn't have any firewall stuff, because by definition, everything's inside your firewall. Now, this is your typical cloud implementation. And the reason that I'm showing this is because many of the things that we're going to be discussing for the next, I guess, 52 minutes are tied to the difference between this diagram and this diagram. Some of the nuances that are shown in here. First of all, what happens is notice that there's no connectivity lines between cloud system 1, 2, and 3. Is that they're all standalone. Secondly, notice that they aren't being run by your nightly production operations. They're being run by the vendors. You know, whenever they do their nightly close, maybe they're just transactional and you're pulling down bunches of data, etc. Third, notice that the central repository doesn't just exist connected directly to the core systems as shown here. What happens is it goes through the production operations. The reason is because, let's say I'll pick on Cloud One. You know what? I should have gone and named them after the, oh, what's his name? Thing 1, Thing 2, Thing 3 from Dr. Seuss. Maybe next time I give this presentation, I'll replace Cloud with Thing just to make it fun. But anyway, so, but you notice here, the Cloud System 1 shown on the upper left. It's outside the firewall. And if I go back to this diagram, what you'll see is System 1 is connected directly to the data repositories. In this case, it's not. So, you know, when I see firewall, you know, company firewall, and I see it going from a system through production, what really is this? This is either real-time feed, or most likely it's a batch feed of some sort. Is you run something in your nightly production cycle, what it does is it goes and executes some process up on the cloud system, and then what happens is that file is downloaded, it's placed in your data repository for use however you're going to use it. And by the way, let's say, for example, that where it needs to be used is System 3, then what happens is that it's downloaded through the firewall from System 1, through a production process that puts it in a data repository, that then there's a second or continued, let me say, production process that then uploads it to Cloud 3 going outside of the firewall. Probably as it's uploaded to that other system, Cloud 3, what'll happen is that there's a process that has to obviously run in that system that allows it to happen. So in effect, going to my third of 3 diagrams, then I get into sort of more traditional stuff, is this. So what happens is your company, you end up with a hub and spoke type data movement and data architecture within your data center. So what happens is inside the firewall, you have all of your data. It'll be uploaded and downloaded from System 1 to Cloud System 1, 2, and 3, as you see here, into the central repository and then moved out to the other cloud type applications that as they are needed. What you will see upon occasion, which is why I have that arrow in the upper right that says if the vendors have a strategic alliance, if by chance you're working with 2 companies, 2 that come to mind are, I believe, if anyone knows differently, let me know, but I believe that Salesforce and Constant Contact have a business alliance. So what happens is that as you're sending out, figuring out what emails to send out through Constant Contact, that you know there's data that can be combined within those. Those that click through can be passed back to Constant Contact. I mean, passed back to Salesforce, etc. So if you're lucky, or if you plan it that way, you know, is that you may find a couple of your vendors that are connected behind the scenes, but that's not through any formal standardization in the industry. It's not through any requirement that most likely you would have the ability to drive. It's just those 2 firms like each other, they're strategic partners, they have complementary products, or any one of a number of other things that goes on here. But basically, this is your architecture. So with this sort of in play, and I might come back to these slides at a future time, but for now, with this backdrop, now let's talk about what some of the operational considerations are regarding cloud computing in general. Remember, by the way, if you have any questions or comments, you agree with what I said, you think what I said is a bunch of baloney, put that in there too. You know, it's again, we have the absolute ability to learn from each other. By the way, if it's baloney, also maybe put in a little ham, because, you know, those go well together. Maybe a slice of cheese and a little bread. Nah, just having fun. But anyway, now let's talk about one of the operational issues with a cloud computing architecture that basically looks like these 2 slides shown here. The first of which is that you're going to have vendor interoperability. The classic example of this, and this, you know, is that the original U.S. abbreviation for German, the country, is GER. Why? It's the first 3 letters of the way we in the United States in English say the word or spell the word German. Well, if anyone's been overseas, that's not what they call themselves. It's Deutschland. So as a result of that, there's an international set of country codes. What the international country code for Germany is DE. So let's say that we're working with multiple vendors. Cloud vendor one is, let's say, very US centric, doesn't use, for some reason, maybe it's historical with them, doesn't use the international code of DE, and they use GER. Then what happens is as you download your data, remember from this, I am going back to it, see, is you're looking at this diagram here. If I have data records in Cloud System 1 in the bottom right and want to pass it to Cloud System 2 in the up on the top, then what happens is think about it. Not only do I have to set up processes to import data via FTP, make sure it's received, make sure it's new data, have failover procedures if it couldn't be downloaded to us, etc. But then I need the same set of requirements going upward to Cloud System 2. But then what else do I have to do? Because of this issue here with differences in coding, is now I have to do translation. So I need code, I need, what's it called? Code tables. Which basically are translation tables, rather, that do a conversion from GER to DE going one way and from DE to GER going the other way. Is it doable? Sure, it's doable. But what happens is every time that you add something like this, another layer of complexity, it brings, well, another layer of complexity, but that also brings an additional level of cost. Why? Because you're going to have to program it. You're going to have to maintain it. It brings another area of risk. Risk meaning instead of GER, you put in GEL for some reason. So what happens is the translation doesn't work in either way, either direction, and therefore you have bad data in one system versus the other. You also have differences in the uploading and downloading protocols. Older systems, you may only be able to download, say, in a fixed record format. Upload it to say a newer technology, they may only accept it in XML format. So as a result of it, not only, let's take that as an additional level of complication. Now, not only are you getting a fixed record, a fixed length record, now you're doing data conversion on some of the fields. Upon doing that data conversion, now what you have to do is then do a format conversion from fixed length to XML in order to do the upload. So as you see, again, none of this is not doable, but these are the hidden costs of moving to a cloud-based architecture. Because doesn't it sound great? Oh, put all of our stuff on the cloud, then we'll just pass the data back and forth. But what you're doing here is, as part of the cost of this, is you're building an entire new data structure, internal data architecture, to be able to facilitate the use of these cloud-based applications. End of the day processing may be different times, or you have different primary keys and or methodologies of how data is collected. So for example, now what might be considered in system 1 is you have, it's say an alphanumeric key. So AB312XYZ is that record or that company's code in the first system, and it's only numeric in the second system. So now you might be able to say, gee, you have now trade-offs. What do you use internally? So now what you might have to say is, gee, you know what? We really like using an alphanumeric key. That's why we went with system 1. But now system 2 becomes crucially important for you to move toward. So what does that mean? You can't use an alphanumeric key there. So do you say, well, it's another translation table, but now this is worse because you're doing key level translation, all right? Or maybe do you say, you know what? You're going to change the key structure that you use internally to only be numeric, and then use only numeric keys, because remember, numeric fits in an alphanumeric format. It's just you're not using letters. So then all of a sudden now, think of the major data conversion that you're doing to go to just numeric. So these are the type of issues that you're going to run into from, a vendor interoperability issue. Now, what I would say to you is that what we're going to be doing in this webinar is we're going to be saying bad stuff, bad stuff, bad stuff. Is that a whole nother webinar, or actually a full day class, would be around the correction or how to deal with these issues. But, what I want to do to you in today's webinar is make you cognizant of these issues, because it's these type issues that are going to make your, that are going to basically save you a lot of pain if you don't think about it, by thinking about them up front rather than farther down the line. The next is portability. Well, you know, you're a cloud vendor A and say, gee, you know what? I want to move to cloud vendor B. Well, what are the chances of actually being able to do it? You know, that is a very new type thing to be a very difficult thing to try to do, because you have contractual, and now not only do you have data movement, but what happens if you go to move to this vendor for good reasons? Now the codes are different. So what happens is you may be developing new code tables, you may be developing new procedures, etc. So as a result of that, you have, you know, contractual issues relating to being able to exit them. It's not like internally where all you had to do to be able to sunset a system was say to one of your is to get the senior VP of something important to say, sorry, Joe, you can't use this system anymore, and have to deal with the political ramifications of it, which, by the way, is the reason that most systems end up not being sunsetted, because there's one senior executive who says, you know, over my dead body, you're going to get rid of the software. But anyway, is that also that there's vendor consolidations? The software may go away behind you. Maybe the vendor goes bankrupt. You know, the biggest example of software going away that I've seen in a long time is, as you know, you may know, many years ago, Oracle bought PeopleSoft. What happened was that PeopleSoft was, you know, great set of financial applications, of course, running off an Oracle platform. What happened was Oracle now is phasing out the PeopleSoft software and moving people to the Oracle platform. So now you have a question. Do you want to go to that Oracle platform? You love PeopleSoft. It's worked great for you for years. But what happens is you're being forced to move because of market forces and let me say industry forces, things outside of your own. So for any cloud-based application, when you sign up for it, what you probably want to say to yourself also is, hey, if I need to, how do I get out of it? You know, because if you've then built, think about it, all of these translation tables and extra processing and all this other stuff behind the scenes, you know, shown on those earlier diagrams, you know, it might be, you know, a short amount of money to transfer from vendor one to vendor two. But what happens is that your internal development costs and so on, and internal disruption in moving from vendor one to vendor two. Because remember, moving to vendor two, vendor one, which is just going away, may have features in it that vendor two doesn't have. So all of a sudden now, not only do you have to do all this data conversion and operational stuff, but now you have to look for additional, to either build or find an additional cloud vendor that meets those other requirements, which is why you selected that other vendor in the first place. Next, runtime monitoring. How do you know that the cloud-based systems are always up? You know, how do you handle the security related to it? You know, these are all very interesting but yet difficult questions to be able to answer. You know, how do you know that the security that you've built internally, you know, is as strong with your vendor? Now, you're probably sitting back and going, well, of course we're going to do due diligence on our cloud-based vendors before we hire them. You know, that goes without saying. IT, by the way, is very, very good at that stuff. But I have a question for you here, and I am not going to ask you to raise your hands on this one. I want you to sit back and think about if you do this or not. This is rhetorical to you. What I want you to answer this question to yourself. You've had various vendors, cloud-based vendors, or just important vendors in IT for the last 3 or 4 years. When was the last time you did a due diligence audit on them? Have you done one since you did the initial due diligence when you purchased that hardware package or a hardware system or software package or whatnot? Now, is Oracle going out of business? No, either is Microsoft or Salesforce or any of the major vendors. But for those vendors that are, you know, smaller, more niche players, no disrespect to them. In my eyes, they have some of the best software in the world. All right, but the thing is they're not as heavily capitalized. They don't make the front page of the Wall Street Journal every time the CEO sneezes. So as a result, it's easy to lose track of what's going on with these systems. They're also much more likely to have financial difficulty or on the move away from the product that you're using to others, or being bought out by a larger vendor specifically for their market base. So when was the last time you did this analysis? Next is that should you want to provide hybrid cloud activities, in other words, integrated in, and this is a story for another day too, but there's a lot of companies, I'll simply say, is that what they've done is that they have their full applications managed using cloud-based technologies inside their firewall. But then what they do is, as the company, as the data for their, as their systems get, say, overrun with higher than expected activity, what they do is they automatically like flip a switch and a certain amount of their processing power goes to the Amazon cloud. In fact, Zynga did this quite a while. They're the ones who write some of those Facebook games like Farmville, Cityville, and stuff like that. There was actually a great story on them in, I think it was CIO Magazine 2 or 3 years ago regarding it. But how can you connect your internal systems to external systems if you're using cloud providers as a PaaS type platform as a system provider to tighter integrate your internal and external systems? Whoops. There we go. Next is multi-tenants. This is an operational issue, I'll tell you, that runs in with me, is manufacturing. Can't even say my own company name. Manager Mechanics. Is what happens is that we're a cloud-based company. We don't, all of our computer processing is up in the cloud. Now, we had two choices when we did this. One is we could use a infrastructure as a service or a platform as a service, basically where we're on our own hardware. Or what we could do for basically pennies on the dollar compared to that approach is to go on shared hardware, what they call multi-tenant. So the Manager Mechanics websites and e-learning platform is on the same Linux box as a whole bunch of other people. I don't even know who. They don't know I'm on it. Basically managed by my internet service provider. Now, as a result of this, is once in a while, that brings certain risks. Once in a while, you get bitten by it. I'll give you an example. Is we were running our email server off of that machine. Not us, but one of the other companies, and I have no idea who they are, that's on that shared tenancy box with our cloud-based vendor, is they were hacked and sent out, tens of millions of junk email all over the place. So what do places like Spam Dragon and the other spam houses do is they flagged the IP address of that machine because it was just going wild, sending out all this junk. Well, guess who also happens to be on that machine? Manager Mechanics. So what happened is that this was actually happening to me. I was emailing back and forth with a client. All of a sudden, in like the blink of an eye, the 4th, 5th, and 6th email that I sent them ended up in spam, and all of a sudden they weren't seeing my stuff. Why? Because their email provider subscribed to one of the services that flagged the IP address of the box that I'm on because of the other tenant physically on that box. So you run into these type issues. Others is if the security of one person one client is compromised, then what that can do is that can bring additional issues for others. So because of all of these things is that multi-tenancy does have its cost advantages, but may have other issues. Another one could be, it says here, usage spikes. So let's say, for example, that everyone in the country wants to go to my website at exactly the same time for some special offer. Then what happens is this the potential, if I drive enough volume to it, is that I may actually hurt the performance of the other people that are physically on that box. So, vendors are very careful to make sure, and they automatically partition numbers of CPUs and stuff to stop that from happening. But nevertheless, that is certainly a greater risk than if I was the only one, if my company was the only one on those boxes. I shouldn't say me, you should say the company. Next is the House of Cards phenomenon. What that is, for anyone who watches TV, this is basically where crooked politicians get into your cloud-based systems. No, I'm just kidding. That is the TV show, though, House of Cards. I actually had this slide built before the series originally came on, or let me say before I knew of the series being on. But I get a lot of laughs when people see it now. But basically what this is, the initial House of Cards concept, which has been around, I mean, since I was a kid, which means like hundreds of years. I don't know if it feels that way. But what it is that if you build little, use playing cards to build like a little house, one of the cards, falls, down comes the whole, the whole structure that you've built. That's the concept behind House of Cards. So now from here, what this means is that if you think of that earlier diagram, let's take a situation now. What that situation is, let's get real on this system, where you have three systems. You have an inventory system. Say, for example, you're using SAP for your cloud-based inventory. You're using Oracle for your financial. So that's accounts receivable, accounts payable, general ledger, etc. But in this case, let's talk specifically about accounts receivable. And let's say that you have in Salesforce, using Salesforce as your CRM. So what happens is, oh, excuse me. I apologize for that. So let's say, for example, that someone stops paying their bill. I'm going to pick on Brian just because, well, why not? So let's say that Brian's company, we have been shipping product to him. And Brian isn't paying his bills. Then what happens is I, in accounts receivable, would know that, that Brian Industries isn't paying its bills. So what do I want to do? Well, I want to tell the people in the inventory, working in the inventory area, hey, don't ship Brian Industries any more product because we're 90 days in arrears. They're not paying their bills to us. I also want to tell the sales force. I want to tell Joe, who's the salesperson for Brian Industries, to give these guys a call, find out what's going on, say, hey, tell them we're not shipping you any more product until you pay us what you owe us. So how did that work in the old days? Let's put those down as system 1, 2, and 3. Well, that's easy. Is that what happens is whenever there's a process in the CRM system, that would be the Salesforce piece, the CRM system that automatically taps into the accounts receivable system to see if Brian Industries is paying their bills. So what happens now is they don't do that because they don't talk. So what are you doing? You're continually bringing transactions and bringing things down into the center repository and feeding them up. So let's say that every time someone pays a bill, or we'll do it just as a nightly process here, is every night accounts receivable from the financials is downloaded into the data center. From the data center, what happens is that it's first fed over to the inventory system, up at SAP in the cloud, and then fed up to Salesforce in the cloud. Well, you know what? Is if the accounts receivable system goes down, or the connection to it for some reason, or that vendor has a bad night, all of a sudden your full processes can't be processed. And maybe during the day when a bill comes in, what you do is the salespeople sell something. They put it in the order system, say in the cloud, I'll just say in Salesforce. And then what does it do when they order it? They automatically send a record to accounts receivable, or a transaction to accounts receivable to say, hey, Brian Industries owes us more money. And they automatically send a record over to the inventory to have it be shipped. If any one of these systems goes down, guess what you need to build into your data repository, that central hub we talked about earlier? All of this logic to handle multi-level transactions, which may or may not have been failed. It's a painful thing because if one of them goes down, they all go down. Now, what this is that if you're interested in cloud security, is you should take as a homework assignment from this to go to the Cloud Security Alliance. Actually, in our full-day cloud course, we actually have a slide on each of these items listed on the left. They have what they call the Notorious 9. which, by the way, I think would be a great name for a rock band. Wouldn't you think of it? Nice punk band, you know, hard rock bands, the Notorious Nine. Either that, or it could be, you know, maybe a good gangster movie, something like that. But anyway, they refer to it as these are the 9 areas where there could be security breaches related to cloud computing. Now, as you look at some of them, you'd say, oh yeah, data breach? Yeah, that's not just cloud computing, that's internally also. Yes, it is, because computing is still computing. With cloud computing, what are you doing? You're just moving it from you to another place, but at the end of the day, it's still the same stuff. So data breach. What data breach is they break into your cloud provider. You know, when everyone says, oh, the internet isn't secure, you know, these cloud providers will have their data, can get their data stolen. Well, you know what? Experience has shown is, quite frankly, so can you. The question is, who's paying more attention to it? And what happens if that data gets stolen? Take big companies, I mean, very successful, well-run IT shops like TJ Maxx, Nordstrom's, Target, many others, Home Depot. I mean, you know, just staples in any mall. These are major companies. I didn't mean to say Staples, the company. I was using the word Staples. I don't think that they've been broken into, but not to my knowledge anyway. But anyway, what happens is that they get broken into, and guess what? Is that they continue. But let's say, for example, you were using some cloud-based application, maybe Salesforce. You were thinking of going to Salesforce, and all of a sudden, you read on the front page of the Wall Street Journal that they were broken into, and now WikiLeaks has every client and every amount of money from IBM and the 8 million other companies that use Salesforce. Are you going to then say, gee, you know what? I think I'm going to go to Salesforce. That will reduce their sales. So what happens is these major cloud-based vendors, security isn't only an important thing to them as it is to your firms and to all firms. It's also that potential Achilles heel that can bring down their business. Less so for, you know, a company who certainly, you know, like I'll pick on Target. Certainly they were embarrassed and they lost lots of money, but you know what? People were still going into their stores and buying products. So think of it from that perspective. Now, data loss is, picture this. You have all of your accounting data in a cloud-based vendor. That vendor goes bankrupt over the weekend. Come Monday morning, you have no general ledger, no accounts receivable, so you don't know who owes you money, and no accounts payable. Guess what you also have come Monday morning? No cash flow and no company. Now, also what you'll find is that if you tie those two together, is how do you stop data loss? Oh, well, you take the data and you put it in multiple places, which does what? It increases the potential for data breach. So understand that these are all different. You know, account hijacking, that's where, you know, you get into someone's account. You know, same old tricks, you know, is that they do phishing, they try to log you into it. They just try every password under the sun until they find out one that works for you. Insecure APIs is that all of these major vendors, they have application programming interfaces. That's API, application programming interface. And then what they do is that they make it easy for programmers to connect to the underlying data structures. Well, not only good guys, but bad guys. So how clearly, you know, how tightly are those managed, the security behind them, etc. Next, denial of service. You know, that's where basically they're hitting your vendor left and right. You know, so what happens is you can't get to that service. Or, by the way, they're hitting you left and right, which means that, let's say, for example, you're using Microsoft 365 in the cloud. And the same pipe that you're using to expose your website to the internet is the one that is bringing in all of your emails. So let's say that Brian and I are sitting in cubes 3 feet apart, is that all the email that he can't send me email, I can't send it to him because we basically lost our connectivity to the street. Malicious insiders, you know, what can you do? That can happen anywhere in any company, even, you know, the government. I mean, it's been shown. Abusing cloud services, that means basically there's been various places where people have, you know, been on Azure or been on the Microsoft, the the Amazon cloud. And what happened was that they were running their own companies on the side and having it being charged through to their employer. Not only can anyone who likes that idea, not only can you get fired for it, but I think you can go to jail. Insufficient due diligence. Like for anybody who's sitting back and thinking, done, or who wrote on their to-do list, do due diligence on company X, that's 8. And 9, the shared technology issues that I'd mentioned before. When we were talking about the joint tenancy, it's possible that someone could break into my site or break into someone else's site and use that as a conduit to get to whoever the other people who happen to be on that box are. And lastly, internet dependency. We'll start with that one. What happens is, think about it. Now you have your, go back to those other 3 applications I mentioned. Oracle, your Oracle financials in the cloud, your inventory and ERP systems on SAP in the cloud, your CRM systems are with Salesforce. Do you know what happens if your internet connectivity goes down? Your accountants will be going out for lunch, your salespeople will be going out for drinks, and your inventory people are going to take the afternoon off. Why? Because none of them can get to the applications that they need. So the more dependent that you become on cloud computing, understand that that level of dependence is also based on the internet. And by the way, you know why the internet, anyway, I'll just skip that, not enough time. But anyway, it's just a bad joke. But anyway, so you have dependencies of it. Now also performance. Brian and I were talking before about connection speed by various internet providers into your place of business. Well, you know what? If that internet link slows down, if your vendors have issues, or for some reason the internet is slow for one reason or another, is what latency is it's the time it takes when you press the carriage return, or the enter key, or click submit, or whatnot, until the application, whatever it's going to do, comes back to you. You click on a About Us button on a website. Latency is the number of seconds or tenths of seconds that it takes to display that on your screen. Now, what I will say is that that I can guarantee you is the speed time that it would take to go from your keyboard to the CPU under your desk back up to your computer screen, hardwired to that CPU, is going to be faster than anything that's going to go over the internet. So what happens is that if the internet slows, or if the application slows, or if your vendor slows, or if your firewall gets needs to be upgraded and it slows bringing transactions through your security to your desktop, every second or two that causes hurts employee productivity. Lastly on this, and then what we do is we'll just quickly move to some data management issues, is that migration of your current systems. I moved a major system once internally at a company I was at, from an internal system to a cloud-based vendor. It ended up working out great vendor and so on. But what I said to my boss is, I said it was a major system that integrated with like every system we had in the company. And I said to my boss, I said, changing from our existing system to this other system is like doing heart-lung transplant surgery on a patient while he or she is running the Boston Marathon. Why? Because you can't miss a trick. You just have to make it work. You got to run in parallel with everybody doing twice. Then when you press that button, it just has to work in both directions. So what I would say to you is, don't underestimate when they say, oh, the cloud, all the software's there, everything's there. Don't underestimate the operational issues and the operational difficulties and the firewall stuff. And all of a sudden now having to create different levels of transactions, which, as mentioned earlier, that, you wanted to commit as a transaction in your inventory system, but then also from there, it better find its way to your accounts receivable or you're giving stuff away for free. So, all of these things, don't underestimate the cost and the complexities of migration. Now let's move to some data management pieces. Whoop. Here we go, sorry about that. Now what this is typical data management. But what happens is this is the life cycle for any data in your company. Data acquisition. I don't mean you bought it, but you might have, but where did it come from? Did it come internally to you from, from something that was created? Did it come from a vendor? Did a customer of yours order something off a website? Then it's data storage. It has to be stored in multiple places. You have to consider where are the backup copies if the systems goes down. What are the backstream systems that it feeds into? What are the physical safeguards around it? For example, you don't want your data server sitting on the heating vent, in your IT manager's office. Regulatory storage issues. Where can or can't you physically put things by law? And if, for example, if you're under HIPAA, if you're in the healthcare industry, then your vendors, all of your cloud-based vendors, if they hold any of your data, they have to be HIPAA compliant too. And data movement, then you have to move it from one place to another, and ultimately data destruction. Data destruction is how do you make sure that when that basically it's properly destroyed so that, it's not on an old hard drive, that's now over at the community school, the community college that was given as a donation. But now let's look at some data-specific situations. The first, each cloud provider has its own data definitions. We talked about that originally, if you remember, as an operational issue. That in fact I have the same code slide up here of DE versus GER. How are you going to protect that? Suggestions? What you need is you need to do some cross-cloud data analysis to find out where the issues are, and then you'd better have all of these cloud-based vendors coming into a single location, so you're only doing the data translation in one specific area. Next, data movement. It will eventually come, hopefully in our lifetime, but there's currently no industry standards to move data from vendor to vendor. If you remember, looking at the original, the third of those original diagrams that I showed you, is that one of them, what they did was, one of the lines went from cloud vendor 1 to cloud vendor 2. They may have that may exist. If you have major vendors that you're working with, you may want to see who they're strategically aligned with, so you don't have to bring everything through your data center. But that's another issue you need to deal with, which brings us down under the suggestions of formalizing a star-based mentality with a data model. Because remember, what's going to happen is that cloud-based computing destroys your corporate data model. It shatters it. Why? Because when you go to Salesforce or you go to any one of the other million quality vendors out there, they all have their own data standards. How long is last name? Do they use the GE or the DER? Also, what it does is it moves it all out of your data center. If you're using Salesforce, then your production CRM system is on their computers, not your computers. That's just the architectural way that it works. So as a result of that, is that the hidden cost, in addition to all of these operational issues that we've talked about in the last 3/4 of an hour, are now also true for your data. The other cost, hidden cost of a cloud-based architecture is the requirement of building a in-house data warehouse in order to do analytics, cross-application type queries, things along that line. Next, intercloud transactions. I alluded to this, but now let's talk about it specifically. You're in Oracle or DB2 or SQL Server. They have what's called transaction commit. So what it is if I have to update things in 3, or I'll just pick on Oracle still, on 3 Oracle tables. Let's say that someone buys product. So someone buys product. The first thing I have to do is go into the account master file table and add them as a customer. Then what I need to do is go to the accounts receivable, and I will put in that they now owe us $50. I'll then go into inventory, and I'll do a deduction of 50 pens that they've ordered to be shipped. From there, or available inventory, I should say. And then what I'll do is I'll go into the ordering system, and I'll get their information that I just pulled from, because I created a customer record for them for the ship to of who it's going to be sent to. And then what I'll do is I'll go to the person whose region that is in the CRM system, and I'll give them, credit for that $50 towards their monthly commission. And then what happens is that in Oracle, what you can do, or all the other major databases, is you post all of those transactions, and then once it's able to do them all, you say commit, and what it does is it commits all 5 or 6 of those SQL insert statements or update statements all at once. Poof. That doesn't happen if you have multiple cloud vendors. Why? Because each one has their own process. So what you get for free in Oracle, if you're doing it all within the same database architecture, is you have to build manually into your processes. So let's say that all those were external vendors. You get to the inventory system, you can't you can't deduct the available inventory by 50 because you can't get in. What do? Do you cancel the whole transaction? Do you set up a special error suspense area so that when that inventory system comes back up, it can automatically do the deduction? Very viable options. But what happens is that you have to build the logic yourself. You don't get it for free inside of a single internal architecture. So that centered in the diagram, nightly production or daily transaction processing, you have to manually build internal software logic to manage all of that. It's neither cheap nor easy, and it's very prone to risk. Data warehouse. That was the other thing that I mentioned here is that you want to let's say then what you want to do is not pass, yes, you're passing data back and forth from different places, but you want to do analytics. The president of the company comes to you as the IT person and says, hey, Brian, what I'd really like to have is a dashboard, corporate level dashboard, which shows me as the CEO of the company, and my direct reports, what is the current sales? What are our inventory levels? What's our aging on accounts receivable? All of these things that go into, call it an executive information system, BI, business intelligence type application, a dashboard, pick the name. What do they say? A rose, in Shakespeare, a rose by any other name would still smell as sweet. It's the same thing, is you need to get all this data in one place in order to be able to develop these type of executive reporting tools. So guess what? You're building a data warehouse, which will mean you're going to be doing data translation. You're going to be doing all those other things we've talked about today. What that brings us to is sort of the end of the informational part. I hope that that's been of value to you, that the information on cloud. What this is some upcoming stuff that we have. The first I'd like to mention to you on the right is in cooperation, and for many years now, we've been doing the certification class. Manager Mechanics is the board of advisors that we have, is the governing body for the ITMLP, which is IT, obviously IT, Management and Leadership Professional Certification, showing these 10 topics are all built into this 3-day class. It's very interactive, very much like drinking through a fire hose. It's actually offered next week, probably a little too soon for you, but it's also offered in May. So if cloud computing, we dig much deeper into this topic as well as the other topics shown here. On May 10th, what we have is a free webinar, which is a 1-hour special, sort of like this one, called What is Your Productivity Cocktail? What it is it's 8 different types of productivity that you can use both personally and professionally. It's things like smart delegation, repurposing of internal assets, knowledge management, personal productivity type time management things, running meetings. So anyway, we're going to be talking about 8 of those. From there, what we're going to be doing, we also have a 1-day class coming up on managing virtual teams, which talks about everything from international culture and the effect that has on multiple teams, to different tools and tricks and ways to run successful virtual meetings. From there, we also have, and you can talk to either us or your New Horizons rep on any of these, is ITLAMP. It's a year-long program where we do monthly webinars, live online instruction monthly on various IT management related topics. We also are building a community of IT leaders through both teleconferences as well as webinars. We also have, it has a number of online tools and references and things along that line. So anyway, with here, what I'd like to do is I'd like to thank you for being on with us. I'd like to thank Brian and New Horizons for hosting us on, I don't know how many of these we've done. It's been maybe 100. But from here, what I'd like to do is turn it back to Brian for any questions that have come in or closing thoughts.
Yeah, we just had one person sent in a comment a little bit back. He just said, the chain is only as strong as the weakest link, which is, as we both know, absolutely true, right? Right, Eric?
Absolutely. I probably did that related to the House of Cards. That yes, is the weakest, your weakest operational cloud vendor can cause you all sorts of problems. It's like parents are only as happy as the problems of as the happiness of their least happy child. Is that as you move to the cloud, remember, the advantage of it is operational ease. But the difficulty of it and the danger, the disadvantage of it is you're giving up operational control. So absolutely, you have to make sure that all your vendors are of an appropriate strength, or it can cause major issue.
Fantastic. And that is all that came in on the question front for you. So I will go ahead. I want to thank everyone that attended the webinar. Thank you so much. We will send out a follow-up email with access to the recording here shortly, probably early this afternoon. And then I want to thank Eric for his time and for what is another great presentation, a great webinar that we're very lucky to have him doing these for us. So thank you, everyone, and thank you, Eric, for doing this for us.
Thank you all, and have a good day.
Have a good day, everyone.